Then where's my screen? Share the screen. And then I can go to Facebook. All right, there we go. So I just want to confirm, guys, before we can start today's lesson, if you all can see my screen that side.
Yes, sir.
All right. I hear some feedback from one person. What about you guys? Can you all see what I'm sharing now?
Yes, sir.
Oh, all right, all right, all right. Then without wasting some time, guys, let me just dive into today's business, whereby we are still extending the business of similarity theorem, but now we moved from those only circles. Now we involve right-angled triangles, like they say here. Okay, we've got this example 20 here, whereby they're saying in the sketch alongside. I'm now here, guys. Here, all right. They're saying the sketch alongside, we are given that the angle BAC is 90 degrees, which is this angle right here. We are given that that angle A there is 90 degrees. And AP here, this one here, we are given that is perpendicular to ABC. That means that this angle and this angle will be 90 degrees. Okay, then now number A is requiring us to prove that triangle ABC is similar to triangle PBA. So triangle ABC is the bigger red triangle, and then we are required to prove that my red triangle here is similar to PBA, to my blue triangle there. So we know now how to prove similarity. That, okay, between the red and the blue triangle, this is going to be the common angle, like they said in this line, okay? And then what's next? Okay, there was this 90 degrees here. It was given also when we go to the red triangle, this will be 90 degrees. Therefore, those angles are equal, reason being given. And then the last one now, we can go to the red triangle, say this angle is equal to this angle in the blue triangle there. Therefore, we proved that these triangles are similar using angle, angle, angle. Then we are done for this part. Does it make sense to everyone, guys?
Sam,
Yes.
I forgot this reason. Well, you see, yeah,
This part. You mean this part?
no,
Which
no,
one?
I mean from A to B. See, it's
From
from A to B. It's opposite. It's what?
which one? I'm not
The
sure which one are you talking about.
ish. So this thing that you're talking about. You see, from
Uh,
A to B.
I was doing this one here, number A, in example 20.
Okay.
So which one were you talking about?
Ish. So I'm talking about the reason from you see A to B, and then there is C. C is
Which, you mean this A, you mean this A here and this B?
no from the diagram.
Okay, okay, okay. From A to B, this line
Yes, yes, and C.
and
It
C, which
yes,
direction? This one.
yes. This
Okay.
it's what's What's the reason, the theorem?
The theorem.
Yes, the reason for that
Oh,
from this C there.
no. For now, there is no theorem that we are required to apply or use. We're just proving the similarities using those angles. So the reason that you're going to provide is when you state some equality between angles. I'm not sure if your question is answered.
Fine, sir.
Sorry?
It's fine. It's good.
What was your question actually? I don't want to leave you with a curiosity.
Sam, I wanted the theorem from A to B, and there is C. C
This
it's
part,
yes.
what is it doing? You want the theorem?
We did it before, yes. The reason for C, I don't know, but this it's perpendicular to the, yeah. I don't know how to explain it, but I'm trying.
Are you not maybe
You
talking
don't get
about
me.
this theorem 3, this part? Are you not talking about this reasoning?
Mm-mm.
You did it with me or maybe at your school?
Yes, with you.
I'm now lost. I'm now lost.
It's fine, so I'll
What
find
was
it.
what was that theorem saying?
Ish. So you see, like when you state a theorem, you say what, and what. Then you say it's prop theorem. Then you state
Oh,
the
oh,
thing.
you mean the first theorem that we did when we were doing the first grade 12 part? This
Yes,
proportionality theorem. A,
yes,
B, C, D, E. This one,
yes,
that's AD over D, B is equal to AE over EC. You mean this one, then prop theorem, and then you
yes.
state your parallel lines, excuse me.
Mm.
Oh no, so now proportionality theorem on this diagram will not apply. Do you know why?
Why?
Now let me ask you this question. There's this, let's say there exists this triangle, that one there that we are given. And then I'm also constructing my other triangle here. Let me construct this triangle here. A, B, C. And I draw some line there that is parallel to BC, and then that line I call it DE. And then now I'm asking you if these triangles are similar or are they the same? This triangle that is drawn there in the textbook, and also this triangle that I just drawn here, are they the same, or we can spot some difference?
No, they're not the same.
Yes. So that proportionality theorem only apply if there exists this line that is parallel to the third side of a triangle. In this triangle, you cannot apply proportionality theorem. Yes, there exists the third line in the triangle here, but this line now is not parallel to one of the side of this existing triangle. Does that make sense?
Yes,
Are you sure?
yes.
All right, thank you then. So is there anyone who've got some question regarding this question, guys? Are you all okay with that question number? Okay, thank you for the feedback. Then we can now proceed to number B, whereby we are now required to prove that a triangle ABC, say a blue triangle, now ABC is similar to the red triangle PAC, this one here. All right, now we can see that this is the common angle in both triangles. Therefore, you can just say C angle C is equal to angle C, like they did in this part. The common angle, okay, we also have this 90 degrees here for the red triangle is equal to that 90 degrees in the blue triangle there, reason being given. Okay, that's what they did there. And then now the third one is going to be this angle is equal to that other angle there, reason being the third angle of a triangle like they did here. Now we have proved that these triangles ABC and triangle PAC, they are similar, reason being angle, angle, angle. Then we are done with that. And then I just want to ask before I can continue to the next question, if it makes sense to everyone, guys.
Yes, sir, we can move.
Yes, sir.
Okay. Okay, I got feedback from two people. What about others? Does it make sense to everyone, guys?
Yes, sir.
All right, thank you for the feedback. Now the last one is this one. Okay, we have proved this, we have proved this. Now we are required to prove that triangle PBA is similar to triangle PAC. And then now we can see that a triangle, which one is common? We've got triangle ABC here is common. When you look in number A and B, this part here, the one that we were proving, this part here, this one, both triangle PBA is similar to triangle ABC and triangle PAC is similar to triangle ABC. Therefore, now you can just come to the conclusion saying, okay, now this triangle here, triangle PBA will automatically be similar to triangle PAC. Reason being, both of them are similar to triangle ABC. Then you are done just like that. Does it make sense?
Yes, sir.
Yes, sir.
Okay, I hear feedback from two people. What about you others, guys? Are you okay?
Yes, sir.
Yes, sir.
All right. All right. Thank you, guys. Then let's proceed to this other theorem, theorem 3. Then this is the last theorem that you will see in grade 12. First theorem was that one, proportionality theorem. The second one, similarity theorem. Now the third one is the Pythagoras theorem, where they are stating that the line is drawn from the vertex at the right angle of a right angled triangle. This line is drawn from that, excuse me, if this is our right angle, the triangle with a right angle, then we construct a line from that 90 degrees there. And that line is going to be perpendicular to the hypotenuse. Okay, this line is going to be perpendicular to the hypotenuse of the bigger triangle. Divides two triangles which are similar to each other and are similar to the bigger triangle. Does this theorem make sense to you guys? Okay, let me repeat, just re-explain this. This is what we just did in that example, the example 20. We proved that this triangle, we proved that that triangle is similar to this triangle. Okay. And then we also proved that this triangle is similar to this triangle. Okay. And then we came to the conclusion that now this triangle here, this one, will be similar to this triangle. Why? Because they both similar to this triangle. So now theorem 3 is saying that if I have my right angled triangle, say A, B, C, and then I construct the line from point A there at the right angle of this right angled triangle, such that this line that I've drawn here will be perpendicular to this hypotenuse of my ABC triangle. Then now we can come to conclusion that this line divides this bigger triangle into two triangles, such that this triangle is similar to this triangle, and both of the two triangles are similar to this blue triangle. That's what this theorem is saying. Let me just now hear if it makes sense to you guys. Oh, I should just re-explain again. Does it make sense to you guys, or you're still confused at some point? Was that a yes, I understand, or
Yes.
yes, you can re-explain?
Yes, I understand, sir.
Oh, all right. Thank you. Thank you for the feedback. I love hearing those feedback. What about others? Do you all understand what I just explained? Where are you guys? You still enjoying the holiday?
No.
Yes. Well, is that a no to maybe no, we didn't understand? How many people are here in the room? Let me then just check. How many people are we having in the room? Oh, 6 people, that's a lot. Sitati Bongani Kim Tamuruma. All right. So does it make sense to you guys so that you can proceed to the next part of the lesson? Or I can explain what you didn't understand? I just want to hear some feedback from you guys.
I understand,
Yes.
sir.
All right, thank you. You understand? I think so far I got some feedback from 2 people that they do understand. What about the other 4? Do you guys understand? All right,
Yes, I understand.
All right, thank you guys for the feedback. Let me then remove my mess here on the screen so that you can proceed to the next part of the lesson. So, okay, I just explained this theorem here. It's what we were proving in the previous example, example 20 in number A, B, and C. So now you've got this diagram here is emphasizing and demonstrating what is being said by the theorem, that if you are given this triangle ABC such that there exists a line PAP that is drawn from the right angle of the right angle triangle, such that that line is perpendicular to BC, then we can come to the conclusion that now triangle ABC is similar to triangle PBA, is similar to triangle PAC. Okay, we know that. Now our reason is that the line from the angle vertex perpendicular to the hypotenuse of the triangle. Okay, now we've got this example 21 here on the screen. We are saying in the sketch alongside triangle ABC. Okay, we are given this triangle ABC, and you can see that this triangle is a right angled triangle. Okay, with some angle there on it, ABC. ABC is 90 degrees. Since it is a right angled triangle, this is 90. Okay, that's a powerful information. And then now the line BP, here we can see, is drawn such that that line BP is perpendicular to line AC. That perpendicularity means that we've got 90 degrees here and also 90 degrees this side. Okay, let's see what we are required to approve then. We are required on number A1, we are required to prove that AB squared is equal to AP times AC. So is there anyone of you guys who can share some idea of how we can approach this problem? It's not that horrible. It's the same as those one that we just did previously when we were dealing with the similarity in circle geometry, whereby you just split that squared part, and then now after doing that, you manipulate your equation so that you have the fraction on the left-hand side and the fraction on the right-hand side. Now you can identify your triangles that you can prove the similarity between the two, and then now formulate the formulas for similarity, and then you can come to the conclusion that something is equal to something, reason being similar triangles. Is there anyone who can give that a try? I'm now giving you guys some chance to try these problems to see if you guys are comfortable with this part of Euclidean geometry, or if you guys understand this part of Euclidean geometry. This is the most challenging part, I think, of Euclidean geometry. So you guys have to use this chance to give these problems a try. And where you don't understand, you ask, we explain, we learn, we move on.
Some girls aspect of some creative sense and more and almost aspect of some like a classmate to someone.
Kavide, can you just please switch off your mic? It's distracting me a little bit this side. Right. And then, all right, thank you. Let me go back to the business. So that's the question. It's requiring us to prove that AB squared is equal to AP times AC. This is the problem I want you guys to give a try. This one. That one right there. Are you guys still there? Or maybe you're just quiet because maybe you're not
Yes, sir. Thank you.
here. Are you still there?
Yes.
Oh, all right, all right. So maybe are you still thinking about how you can approach the problem? Or it's a little bit difficult so that maybe I can go through with you guys?
I'm muted. Sir,
Yes, sir.
Yes?
I think I can try.
Oh, okay. You're more than welcome to do so. You can give it a try. I'd love that.
Okay, so I use the method whereby we equate the like similar sides to one another and then manipulate the equation, right? So I said AB
Mm-hmm.
over
Okay,
AC.
let me write what you just saying. You're saying, you'll correct me if maybe I read something that you didn't say. You're saying you said
Okay.
AB,
Yes, sir. Over
yes,
AC. And then I
you're
said
saying you
equal
said
to
AB over AC,
AC equal
okay,
to A,
equal to
AP over AB.
AP over AB,
AB.
okay?
Yes, sir. And then I cross multiply the denominators, meaning I move AC to the other side and AB to the other side.
So what you did, you just cross multiplied this
Yeah.
and that.
Yes, sir.
Okay, then that gave you something like similar to the question, AB squared is equal to AP
A-
times AC.
Yes, sir.
Okay, is, is this only what you did?
Yes, sir.
Uh,
That's where I ended.
how did you get to this part so that now I can be convinced that okay, this is equal
I
to
checked
this.
with the triangle, sir, I checked like the similar sides of the triangle. So the hypotenuse of the two triangles, because I separated the two triangles, right? From what was given, I looked at the like specific angle. I don't know, because I think I need to have a reason why I did that. But then all I did was check the triangles, basically the angles that were given in the question, and not use the question and rather compare, check the hypotenuse of the angles, put them
Okay,
over each other, and then the other corresponding angles of the triangle over each other. I'm just struggling with the reason.
okay. Wait, what did you want to achieve now when you were doing that? So that maybe
To
I can help you.
with that, I wanted to get to the part where they said prove that those whatever that is equal to that. So without using necessarily what was given, I rather use the angles that were there to check for the triangles and then get to that point using that method of multiplying.
Oh, okay. So this is what you can do. Let me just start with what we first did when we were doing this similarity thing. Remember, first we were required to prove that maybe the angle ABC is similar to triangle maybe DEF. You remember this part, right?
Yes, sir.
So with this part, when we were continuing with those previous lessons, we came to this part where we said we can formulate these formulas that we can come to the left triangle, say this AB over DC, this
Yes.
AB over DC is equal to maybe this BC over CF, BC over CF, that is equal to, we come to the outer ones now, AC over
Yes.
DF. We come
So
to
I can
this.
use that then that sides of triangles in proportion.
Sorry?
I can use the reason sides of triangle in proportion.
Where, when you get to this part?
Yes, sir.
I'm not sure if that
Not
reason
here.
is allowed, but the one that I'm sure that it's correct and he can give you marks for this part, you can just say similar triangles.
Oh, okay, sir.
Yes, just to come with this formula. After you can only create these formulas here, these ones, only if now you are sure and have proved that this triangle is similar to that other triangle. If you haven't proved that these triangles are similar, you cannot come to this conclusion because this conclusion is going to need those triangles to be similar.
Oh, okay, sir.
You get this part.
Yes, I get it. So basically, more like the exercise we did before this one. I have to prove the triangles. I have to prove that the triangles are similar before I get to the part where I can equate the sides of the triangle.
Yes, you must be convinced first that those triangles are similar.
Oh, okay, sir.
Yes, good try though. I love it. Then now, from this part now of proving this, let me come to this part. Then after we were given somewhere, at first we were given that prove maybe that triangle ABC is similar to triangle DEF. Now we were just required to prove something like this. We somehow were required to prove maybe that AB over BC is equal to, what was it? Maybe AD over DF. Now, you're not sure about which triangle you're going to take to prove similarity between. So, okay, you can either come to this part and see if those letters can give you the triangle, and then now you can come also to these letters and see if they can give you triangle. So, okay, with that numerators, you can see that we can have triangle. Okay, we have got A here, we have got A, we've got B and D. Numerator can give us the triangle ABD. Okay, let's go to the denominator. We've got we've got B, C, D, F. We've got 4 letters. Okay, now we can go for the numerator and denominator to check if they can give us the triangles. Let's check now the left-hand side and the right-hand side if they can give us a triangle. You go like this, now you see, okay, I've got A, B, C, 3 letters. Now they can give me the triangle A, B, C. Okay, I'm going to prove the similarity between that triangle. And now I have A, D, D, F. Okay, I have triangle A, DF. Now, okay, it works for me now in this scenario. If I go for the left-hand side on the triangle and the right-hand side, not the numerator and the denominator. So does this part make sense to you guys?
Yes.
Yes. Now, after extracting this triangle, okay, you know now that, okay, I'm required to prove the similarity between these triangles. And then now you take it from there, you do what you all know to prove similarity. You continue with your question. And then when you proved, when you have proved that these triangles are similar, then now you can create those equalities that, okay, I'm sorry for that. But AB, you can come to the conclusion now that AB over AD is equal to BC over DF. They are all equal to AC all over AF. Then your reasoning is going to be similar triangles after you have proved that those triangles are similar. Okay. Then if that makes sense to you guys, then let's go to this example 21 here that we were using. Okay. There's this way that they use. You can also go for this way that I was just explaining now here. Let's first just go through the way that they did now here. They did it like this. Okay. They were required to prove that AB squared is equal to AP times AC. Okay, and then they went to the triangle that we are given there using the theorem. Okay, I was given that bigger triangle, and then there was also that line from the right angle there, such that it was perpendicular to the hypotenuse of the bigger triangle. Now, that theorem there, this one is saying, if there's something like this, now I know that this triangle will be similar to this triangle, and those two triangles will be similar to that triangle. Then you state this reason. So now, if you are sure with your similarities, now because it was proven this using that theorem there, now you can come to your triangles that, okay, I've got triangle ABC here. I also have triangle APB, APB here, and then I also have triangle PAC. And then now, with those triangles, you can just formulate those equalities that, okay, now in this case, AB over AP will be equal to BC over BP. They all will be equal to AC over AP. Until now, you have something that you know that it can help you like this one, and then you cross multiply from those formulas up until you come to the conclusion that AB squared is equal to AP times AC. Does this way of theirs make sense to you guys? Oh, there is someone who's still curious about something.
Yes, sir.
Does it make sense? Oh, I heard feedback
Yes, sir.
from Oh, all right, thank you.
Yes,
Guys.
sir.
So this is their way to go for it. But if maybe it happens that you guys forgot this theorem here, this theorem, okay, it's fine. If you forgot that there are many ways to kill a cat in mathematics. So what you can do, you can come to this part. Okay, you've got AB squared that we can write like this, AB times AB is equal to, that is equal to AP, that is equal to AP times AC. All right, AC. And then now we can create something here. We divide by this on that right-hand side. We divide by this on left-hand side. Therefore, that is going to give us AB all over AP is equal to AC all over AB. And then now when you get to this part, now you can extract the triangles that you're going to prove the similarities between. Okay, let's first go for the numerator and see if we can just extract some triangle there. And let's come to this part. We have got B, C. Then that gives us a triangle there, ABC. All right. Then you can also go for the other denominator and see if it can give us the triangle. A is there, okay, P and B, 3 letters, they can give us a triangle, APB. APB is this one right here. Therefore, now you can just prove the similarities between the triangle APB, AP, B and triangle ABC, ABC. And then after you have proved this, then now you can just go play around your formulas. Then that equality, you're going to support it using the reason similar triangles. And then now you will take the equality that will give you something that will lead you to this solution here. Does it make sense to you guys, this one? You can either go for this one whereby you're just going to extract your own triangle, or you can, if it's only this scenario whereby there is that theorem whereby there is a right angle triangle with a line from the right angle perpendicular to the hypotenuse. You can go for the one that you think it can be easy for you. I just want to ensure if this one that I just have explained now makes sense to you guys. Do you guys get it? All right. Thank you, guys. Let me then remove this mess here. So this question here for number B, for number 2, this one you are going to do is the same way you did the first one, and then it's just that the last one in number B here is requiring you to use this part now to prove this Pythagoras theorem here, that AB squared plus BC squared is equal to AC squared. So how are you going to do that? This is what you're going to do. Okay, what is AB squared? AB squared, you have it there is AP times AC, okay, plus BC squared is PC times AC. We have AC as a common factor here, therefore we can just factorize AC, and inside the brackets being left with AP plus PC. All right, we have got AC times AP plus PC. We have got AP, that part, plus PC, and then those two parts gives me AC. So we've got AC times AC. This gives me AC squared. Therefore, we've proved that AC squared is equal to AB squared plus BC squared, just like that. You have proved this Pythagoras theorem. Does this one make sense to you guys?
Please repeat it, last answer.
All right. So let me just re-explain it from the start. And then we are required to prove that AB squared plus BC squared is equal to AC squared. Okay, so what we can do now, because we know what AB squared is in terms of other letters from number 1 here, we can write that AB squared as AP times AC. Why? Because that AB squared there is given as AP times AC. Okay, plus then BC, this one here, it can BC squared, it can be given as PC times AC, PC times AC. Then before I can continue any further, I just want to ask if it makes sense up to so far to you.
Yes, sir.
Okay.
Yes, sir.
Now, all right.
Yes,
Thank you
sir.
guys for the feedback. Now we can see that we have got AC at this factor. We also have got AC in this factor. Therefore, we can factorize AC. We can have something like AC inside the brackets be left with AP plus PC. All right. Therefore, we've got AC inside our brackets. We've got AP plus PC. When you go to the diagram, you can see that this AP is this part here. And then this other PC is this part here. Those two parts, when I add them up, they give me AC. That is why I say this AC times this part here gave me AC here. Therefore, I've got AC times AC, which is just AC squared. Then now I have proved that AC squared is equal to AB squared. That was equal to this part. And then plus BC squared. That was equal to this part. Then you are done, just like that. Does it now make sense to you guys?
Yes, sir.
Yes, sir.
Are you guys sure?
Yes.
All right, thank you guys. So
100%.
is there anyone of you guys who have got some question or who's curious about something that we just did in tonight's lesson so that I can explain before I log out of the lesson? Or you guys are all okay?
Sir,
Yes?
for like example A, when we have to prove what is given there, can we use the reason that is given in the solution, whereby we just write the triangle ABC is similar to triangle APB and use that reason instead of proving the angle?
You mean this one?
Yes, sir. That reason given there. Is it follow? Oh,
This,
okay, I see. We should prove
this
the
reason?
angles first. Yes, sir.
Oh, no. You don't have to prove in this scenario whereby there is the right angle triangle and there is that line drawn from the right angle triangle and is perpendicular to the hypotenuse. You don't have to prove if you go for this one. You just write this thing here and then write the reason, because that is from theorem 3. You don't have to
Oh,
prove
okay,
anything
sir.
if you go for this one.
Okay, sir.
Yes. Was that all that you wanted
Yes,
to
sir.
ask? Oh,
Yes,
okay,
sir.
okay. Is there anyone of you guys who want to ask any question before I can log out of the lesson? Or you all are cool? What are we now left with? Oh, we are now done. We will be doing the proof of these theorems in the next lesson. Are you guys okay with everything that we just did in tonight's lesson?
Yes, sir.
Oh, all right then, guys. Thank you for being with me in tonight's lesson. I'll just see you in the next session that we will be having next week. Have a good night, guys. I'm now logging out of the lesson.
Bye.